Alright, so my name is Jason. I'm from Berkeley Heights. I'm going to be a senior at Union County Magnet High School in the summer. Today's mods in chat are Ethan and Harsh. Say hi, Ethan and Harsh. So yeah, we already got through the questions. So you guys can see me, hear me. Alright, we're all good. Alright, a reminder that all children under the age of 13 should be accompanied by parents for privacy reasons. Do not put any personal information out there on the internet. And our mods will try to remove any comments that do reveal personal information. This includes your full name, address, phone number, and email address, among other things. Let's review the stuff we went over last time. Alright, so batteries provide voltage and power to our circuit. They are our power source. Of course, a wall outlet sometimes is another power source, but in this case we're using batteries. They are safer, and we don't working with the wall outlet is sometimes a pain. The battery holders, we want to hold multiple batteries, and this will allow them to basically be one battery with more capacity. Okay, resistors, they resist current, the flow of electricity, that is. LEDs, light emitting diodes. Does anybody know what a diode is? Did we go over this? Not LED. LED is a light emitting diode, but what is a diode in general? Alright, well, I'm going to go on. A diode is a electrical component that only allows flow in one direction. Ah, okay, so M-Ho actually said that. Yes, good job. Kudos to you. Okay, piezoelectric buzzers, they produce sound from electricity. And if you vary the voltage, I believe, they should be able to produce different sounds. So when we put a resistor on them, we should have some slightly different sound. Buttons, they switch the circuit from open to closed and vice versa. They can be placed, keep in mind that buttons can be placed anywhere in a circuit, and they will still function the same way because their job is to break the circuit and reconnect the circuit. Circuits, so a closed loop forces electrons to flow from the positive terminal to the negative terminal. I don't think this is actually correct. I think electrons will flow from the negative terminal to the positive terminal, as electrons have a negative charge. But you know that's picking. That's really being picky. Either way, what you guys need to know is as the electricity flows through, everything in the way, like the light bulbs, will be powered. An open circuit, however, will not, because they can't complete the path, so they will not have, you won't get any power to any of the components in the circuit. A series circuit has one path for current, it's the one on the top. As you can see, the bulbs are one after the other, so it's in a series. Whereas the parallel circuits have multiple paths for the current. Those two bulbs on the bottom are in parallel. Does anyone have any questions about any of the concepts that we just reviewed? I know I went a bit fast through them. Alright, well, as of now, no questions. If you have any, the mods will be happy to answer them. Let's go on to electric motors. So electric motors are very important to robotics, which are pretty fun and a very nice application of a lot of the concepts we are teaching here. If you want to get more involved with electronics, a great idea is to in fact get into a robotics club, and I would recommend this a lot. Motors are one of the most important things because they move things, and in the end, a robot has to move. Before we go through motors, I want to go through the concept of energy. You might have been taught from about the various forms of energy in school. Electrical energy is namely the one we are working with the most. I think you guys probably can name a few other forms of energy for me, right? Can anyone name a few forms of energy? I already named electrical energy. That is the type of energy we are working with today, mainly. Chemical energy, good. Potential energy. So potential energy is a bit different, as there are multiple forms of energy. So it's more of a general thing. Kinetic energy, very good. For example, gravity is a type of potential energy, but chemical energy in general is also potential energy. Nuclear energy. Solar energy, so the energy of light is an energy, but we don't generally call it solar energy because it doesn't have to come from the sun. Solar energy is more generally called radiant energy. It is the... Oh, sorry. Yeah, it's the energy of electromagnetic radiation, including light. Yeah. Thermal energy. Good, good. Alright. That being said, what form of energy does an LED convert electrical energy into? So you guys might know that energy cannot be destroyed or created, and it can only be converted into various forms. So what form of energy does an LED convert electrical energy into? Radiant energy, very good. Light energy, radiant energy is correct. How about a buzzer? What form of energy does a buzzer convert electrical energy into? This one's actually a bit hard because the energy of sound is a sound energy is actually mechanical energy because the motion in the air. Yes, sound energy is mechanical energy because of the motion in the air in the form of sound waves hits your ears. If you guys want to learn more about that, we can talk about it after the stream. We'll probably have a bit of extra time. I can explain a bit more. How about a battery? A battery will convert a certain type of energy into electrical energy. Chemical energy, yes. Chemical energy is correct. Because a battery stores its energy in the form of, in this case I think we're working with nickel, some sort of nickel battery, but generally some sort of substance that will release its charge when it can. A motor does the same thing as all these other components. They convert one energy into another. In general, a motor converts some sort of energy into mechanical energy. This can be chemical energy into mechanical energy. For example, in an internal combustion engine, like in your car, the gasoline's ignition converts chemical energy into mechanical energy. In the case of the motors we're looking with, obviously we're converting electrical energy into mechanical energy. With that in mind, let's take a look at how motors achieve this energy transfer. Alright, so electrical motors convert electrical energy into mechanical energy. These motors rely on various concepts in electromagnetism. If you want to know specifically Lenz's law, if you want to go Google that at some point for further reading. Unfortunately, the subject is very difficult. It involves very complex math when you get into it. So we're going to briefly summarize. In a motor, generally there are two parts, a spinning rotor and a stationary stator. On these parts, usually there will be coils of wire, and you'll see this in the next slide. And and or magnets. When current is run through these coils of wire, it interacts with the magnets in a way that produces a spinning motion. On the right side is like a slow motion way of how it works. On the left side is the original speed of the GIF. If you see, the coils here have current running through them, and so they are magnetized. They will be naturally attracted or repelled from the magnets on the outside, and this will create a bit of spinning motion. This is the basic concept of a motor right here. Alright, I've talked probably long enough about how these motors work, so let's just get to wiring one. So this is the basic circuit you guys will need. It'll just be a battery into a button switch into the motor, and give me a second to switch over to the proper to the desk view. Okay. So, let's get on with making our circuit. I'm going to start with the battery pack. We're also going to need a motor. I put a little flag on this motor. This is for the purposes of demonstrating its spinning motion a bit easier. And we will need a button. Where'd my button go? Where's my button? Okay. And a few wires, of course. So, I like to connect power at the very last stage. Generally, this is a very good idea. That way, it doesn't accidentally go live until we are ready to make it go live. So I'm going to start by putting 2 wires on my button. Alright. I'm going to attach one end to my motor and leave the other end. I'll use a red wire for this. And the other end I will leave to connect to my battery pack at the last stage. Alright, now let's connect the battery pack. One end will be attached to the negative side of the motor. I'm doing this. Okay, sorry. I was a bit out of frame there. So the first thing we did was connect 2 wires to the button. Next, we connected one end of the wire to the motor's wire. The other end of the motor we will connect right now to the battery pack. If I can get it to work. Okay. The other end of the 2 wires we connected to the button will also go onto the battery pack. And that should be it. So when we press the button, you will see our motor spinning when I turn on the button. And that is the basic circuit to create a motor. Okay. Were you guys able to do this? Did you have any trouble? It's a fairly simple circuit. We are more or less just substituting our LED and resistor for a motor. It works. Great. Good to hear. Generally, it's kind of hard to see if it works. You know, the shaft spinning is a bit... you'll probably see it and hear it. If you want, you can tape something onto it. Like, I just put a bit of electrical tape. It makes it much easier to see if it's spinning and how fast it's spinning. That's great that you guys did it. All right. So next I'm going to show you guys something that, it's a bit of extra content, if you will. This is this is changing. This is going to be me changing the voltage going to the motor. This will change the speed. This is a bit difficult to explain. Let's go to desk view. I have this thing here. This is a variable voltage power supply. It will supply between 3 and 12 volts of electricity at 1 amp. If you know anything about our batteries, or you read them, I believe they say 1.5 volts. So when you use these batteries, you get 1.5 volts of electricity. Now, this power supply plugs into the wall, and it has a switch here that slides between various voltages. On the other end, I will connect it the same way I connected the battery, and so I can get variable voltage. And I just want to demonstrate how voltage changes the speed of a motor. So I'm going to plug it in, and I'm going to do basically the same thing, except I'm going to substitute the battery for this power supply. And I'd advise not doing this at home, by the way. My solution is a bit what I like to call janky, and it has a bit of exposed metal. So you do run the risk of electrocuting yourself, and believe me, it does hurt. But you know what? I am experienced, and I'm not going to do that, hopefully. So, right now I have it set to 3 volts. This is already double the voltage of the batteries that are giving it, so it should go pretty fast. Now, I'm not sure if you guys can see that too well. It's kind of blurry. But maybe the sound works? Alright, so it's already going faster than it did on the batteries. So now we're going to step it up to 5 volts. 4.5 volts first, sorry. So this is 3 times the voltage of a battery. And I'm going to go ahead, turn it on. And just from the sound, it's already a lot faster. And it's actually shaking my hand because it's going pretty fast. Alright, and finally I'm going to step it up to 5 volts. I'm not going to step it up any farther despite my power supply going to 12 volts. I run the risk of burning out the motor if I run it at a high voltage for too long. So I'm just going to step it up to 5 volts. That's our final setting. From the sound, or maybe from the camera, you can see it's going much faster. And so that's just a bit of a demonstration into how voltage affects the speed of a motor. Now, while doing this by hand on a power supply is a bit clunky, there are devices out there called motor controllers that will do this automatically for you. You can write a program, for example, to tell the motor controller to give a certain voltage. And this will change the speed of a motor. Alright, so that's that. I think that was pretty cool. What do you guys think? Very cool. Alright, thanks. Yeah, this is a basic concept of the motor controller, which is how, in the end, we can control the speed and direction of things like RC cars, robots, etc. This is very important to that concept of control. It's always great to learn. And one more little bonus thing. I'm gonna take a look at a floppy disk drive. I hope this will illustrate what I talked about between the coils and the magnet. If you guys don't know, a floppy disk drive, old way of storing media. They're kind of obsolete now, but you used to put these into your computer and, you know, you get a few megabytes of storage. I've already taken apart a drive, and in a second I'm going to go back to desk view and I'm going to show you the internals of a motor, because I think this is really illustrative of how the motor works. Okay, this is a floppy disk drive. You put your disk in, like so, and it'll go in, and then it'll read your data and let your computer know what's on it. So I have already unscrewed the drive, so I'm going to take apart the casing. Do not do this on your own computer equipment without first asking your parents if it's okay. But here is the main part I am interested in, right here. So this is the main circuit board of a floppy disk drive, and in the middle is this very large motor. So this will spin a floppy disk, and obviously CDs will have something similar as well. So this actually just comes off. This is what I said was the rotor of the floppy disk drive. This is what spins. And on the other hand, this is the stator right here. So let me bring this up a little more. Okay, these blue things here are the coils I was talking about. As they get current through them, they will produce a magnetic field. And there's a magnet. This gray ring on the rotor is a magnet. So the magnetic field's interactions with the magnet will spin this rotor, and this rotor will attach to the floppy disk at this metal point, spinning the disk, allowing your data to be read. Nowadays, CDs and floppy disks have gone the way of have really become obsolete. Solid state memory and hard drives have taken over, but I feel like this old tech, this cool motor in the floppy disk really shows you a use of the motor and shows you a great example of the internals of a motor. This is specifically a brushless DC motor, if you guys want to look into that more. But what that means is that there's very little contact between the rotor and the stator, and that allows for very efficient power usage, which is very nice. Don't want to be paying extra for inefficient power use. This board already has a built-in motor controller to control the speed of the motor to keep it at a very constant rate. Alright, I hope you guys thought that was cool. A record player. I would not recommend taking apart a record player. I think they still have some use. Records are still being produced, believe it or not, for new music. And a lot of music sounds very nice on vinyl. So maybe don't take that one apart. But a record player will have a much larger motor because it has to spin the record. But yeah, that's another great use of records. Of motors. Sorry, I slipped there. So that is it for today. I hope the two bonus examples were instructional. Solid state drive work. That is a whole new... Alright, so MHO just asked, how does a solid state drive work? That is a difficult question to answer. I would recommend you looking it up yourself. I hope you find something useful. It uses flash memory. I believe NAND flash might be a keyword that helps you. But the solid state drive works in a completely different way. It has no moving parts, which is an advantage, and an advantage to the hard disk drive or the floppy disk or the CD or the DVD or etc. Yeah, it has no moving parts. That's the main feature of it. Instead, it uses flash memory, and I'll leave it at that. Any further knowledge you want, go ahead, try it out yourself. Try to find it yourself, I should say. That is it for today. Next live stream will be next Wednesday, and it will be August 19th. We're going to be creating a fan with our new knowledge of motors. Any questions now is the time to ask. I will be staying on a bit. I can answer questions, as can the mods. Yeah, I think that's it, though. Thank you guys for coming. Have a very nice day. I hope you guys learned something new.